All right, let's dive into this quantum computing thing. Everyone keeps saying it's a game changer, but like, how? What's the big deal?
It really is a whole different world. And the hype, it's not just hype. This research paper, Quantum Computing,
Hmm.
Applications and Implications, it lays it all out, both the techie stuff and how it'll change, well, everything.
So, where do we even begin with something this complex? I mean, I get that quantum computers are supposed to be super powerful, but how do they even work? They're not just souped up versions of the computers we use every day, right?
Yeah, it's not about speed exactly. Think of it this way. Regular computers use bits, a 1 or a 0, like an on-off switch.
Gotcha. Binary code ones and zeros. That's how our computers think.
Now, quantum computers use qubits. Imagine a dimmer switch instead of a light switch.
A dimmer switch. Okay, that's an interesting analogy. So, how does that make a qubit different from a regular bit?
Because a dimmer switch can be on, off, or anywhere in between, right? A qubit's the same. It can be a 1, a 0, or both at the same time. That's called superposition.
Whoa, hold on. It can be both at the same time. That's mind blowing. So, if one qubit can be two things at once, does that mean a quantum computer with, say, 10 qubits is like a regular computer with 20 bits?
Not even close. It's
Yeah.
way more powerful than that. The real game changer is when you connect multiple qubits, something called entanglement.
Entanglement. Okay, that rings a bell. Isn't that what Einstein called spooky action at a distance?
Yeah, it's like two qubits are linked no matter how far apart they are. Do something to one, it instantly affects the other. It's like magic, but it's quantum physics, and it lets these computers do things classical computers just can't even dream of.
Okay, I'm starting to get it, but my head's spinning a little. So they use superposition, entanglement, all this quantum weirdness to crunch numbers in a totally new way. But what does that actually let us do? What's the practical application?
Well, think about cryptography. The whole system of keeping information secret online. Right now, the encryption we use, it's tough for our computers to crack.
And not for quantum computers, huh?
You're catching on. Algorithms like Shor's algorithm, a quantum computer could blow through a lot of today's encryption like it's nothing.
That's a bit unnerving. So all our online data is potentially vulnerable, our bank accounts, our personal information, everything.
It's a huge concern, and governments, companies, they're racing to create new encryption methods that can stand up to quantum computers.
So it's a cyber arms race, essentially. Quantum computers breaking the codes and everyone else trying to stay one step ahead.
You could say that. But it's not just about cybersecurity. This paper talks about drug discovery, materials science fields, where quantum computing could totally change the game.
Okay, let's break that down. How could quantum computers revolutionize something like drug discovery?
Think about how new drugs are developed now. Tons of trial and error, it takes forever and costs a fortune. With quantum computers, we could simulate molecules, how drugs interact with the body, at an atomic level.
So, designing and testing new drugs entirely in a computer, that could be a game changer for healthcare. What about materials science? What's the potential there?
Similar idea. We could design materials with specific properties, super strong, super efficient, things we haven't even imagined. Think solar panels that capture way more energy or batteries that last for years and years.
It sounds like we're talking about solving some of the world's biggest problems: climate change, energy dependence, maybe even curing diseases. It's almost too good to be true. But there must be some downsides, right? Quantum computers can't be perfect at everything.
You're right, they're not magic. They're really good at specific types of problems, but your laptop, it's not going anywhere, at least not yet.
So we're not all going to have quantum computers on our desks anytime soon. What's holding them back?
It's still early days. One big challenge is building them with enough qubits. The best ones now have a few hundred, but to really tackle those big problems, we might need millions.
Okay, so size matters. What else?
Qubits, they're super sensitive. Any little disturbance can cause errors, so figuring out error correction, that's huge.
And I imagine the software is a whole other challenge, right? Programming a quantum computer must be totally different from anything we do now.
It is. New languages, new algorithms, we're practically starting from scratch.
Huh.
So, yeah, lots of work to be done, but the progress, it's amazing.
It is exciting to think about all this potential, but it's important to be realistic too. This research paper, it doesn't just focus on the good stuff, right? It talks about the risks, the potential downsides of quantum computing.
That's what makes it so valuable. And
Yeah.
yeah, some of the stuff, it's a little scary, like we talked about encryption, but imagine this tech in the wrong hands.
Yeah, a powerful tool can be used for good or for bad. What are some other potential risks we should be thinking about?
Economic disruption is a big one. Quantum computing, it'll create new industries, but could wipe out others. Job losses, inequality, it's something we need to prepare for.
So it's not just about the technology itself, but how we manage its impact on society.
We can't just sit back and watch this unfold. We need to be having these conversations now about ethics, about regulation, about the kind of future we want to build with this technology.
It's a call to action, isn't it? This research is saying, hey, this is happening, and we all have a responsibility to shape it in a positive direction.
Exactly. It's on all of us scientists, policymakers, the public, to make sure this technology is used for good, not for harm.
Okay, so we've covered a lot of ground here in this first part. The basics of quantum computing, some mind-blowing applications, and some serious risks to consider.
It's a lot to take in, but it's just the tip of the iceberg. There's so much more to explore.
This is definitely a conversation we need to continue. Listeners, stick with us as we delve deeper into this fascinating and complex world of quantum computing.
So we're talking quantum computers, powerful enough to crack any code, but this paper, it goes even further, right? This technological singularity thing kind of freaks me out, not gonna lie.
Yeah, this is where it starts to feel like we're stepping into science fiction territory. For our listeners who haven't heard of it, what exactly is this singularity everyone's talking about?
Basically, the idea is that AI, artificial intelligence, is going to get so smart so fast, it just blows past human intelligence. And then, well, things change fast in ways we can't even imagine.
So it's not just about AI that can write a better poem or beat us at chess. We're talking about AI that designs its own AI, solves problems we haven't even thought of, reshaping the world according to its own, agenda.
That's the idea. And this paper, it argues, quantum computing could be what kicks this whole thing into overdrive. Not if, but when. That's what a lot of experts are saying.
Makes sense. I mean, we've already talked about the potential for quantum computers to revolutionize medicine, energy, materials. Imagine that kind of power in the hands of an AI that's smarter than any human.
It's mind-blowing and a little scary too, right? Cures for diseases, solutions to climate change. But what if this super intelligent AI decides humans are the problem?
Yeah, that's the fear, isn't it? If we create something that smart, how do we control it? How do we make sure it's aligned with human values, human goals? It's almost impossible to grasp what an intelligence that powerful would even be like, let alone predict how it would behave.
Exactly. Those are the questions we got to be asking now, not later. This isn't just some abstract future problem. This is happening, and the stakes, they're higher than ever.
This paper stresses that, doesn't it? It's like a wake-up call. Quantum computing isn't just coming, it's here, and we better start figuring out the ethical implications before it's too late.
Totally. It's not about predicting the future, but about thinking ahead, about the potential pitfalls and making sure we're prepared. It's about choices.
Okay, so beyond this singularity, what else does this research highlight about the long-term impacts of quantum computing? It feels like we've just scratched the surface here.
Oh, there's so much. One thing that caught my eye is space exploration. Think about designing spacecraft with quantum computers, ships that could actually travel to other stars, or simulate what it's like on those planets, see if they could support life.
Talk about science fiction becoming reality, but let's get back down to earth for a second. What about the economic side of things? We've touched on how some jobs could be lost, but could quantum computing actually reshape the entire global economy?
This research suggests it could. The countries, the companies that master this technology, they'll have a huge advantage. They'll be able to solve problems, develop new technologies, make decisions faster and more efficiently than anyone else.
So we could see a major shift in global power as nations race to become quantum leaders.
Absolutely. And it raises a big question. Who gets access to this power? Will it be concentrated in the hands of a few wealthy nations and corporations, or will we find a way to share the benefits more broadly?
That's a crucial point. The last thing we need is a technology that widens the gap between the haves and have-nots.
And it's not just about countries. It's about individuals, too. What happens to people whose jobs are automated away by quantum computers? How do we prepare for a world where some skills are no longer needed, but new ones, like quantum programming, become essential?
It sounds like a massive societal shift.
It is. And this paper is calling on us to start planning for that shift now. Education, retraining programs, social safety nets. We need to make sure everyone benefits from this quantum revolution, not just a select few.
It's about being proactive, about recognizing that we have the power to shape the future, even when faced with something as complex and potentially disruptive as quantum computing.
Exactly. We often feel helpless when it comes to technology, like it's this force we can't control. But that's not true. We have choices to make. We have a say in what the future looks like.
That's an important message for our listeners to take away. The future isn't something that just happens to us, it's something we create together.
Mhm.
So we've covered a lot of ground, right? Quantum computers cracking codes, this whole singularity thing. It's a lot to process.
It is, but this research, it doesn't just dwell on the scary stuff. It keeps bringing me back to the human side of all this.
Right, it's easy to get lost in the tech jargon and the mind-blowing possibilities, but at the end of the day, it's about how this impacts people's lives, right?
Exactly. And one area where that impact's going to be huge is the job market. We touched on job displacement, but its paper goes deeper. It's not just about fewer jobs, but a total shift in what skills are going to be valuable.
So not just fewer jobs, but different types of jobs. What kind of skills are we talking about here?
Well, yeah, we'll need quantum programmers, engineers, the folks who can actually build and run these machines, write the software.
Sure, that makes sense. But what about those of us who aren't, tech geniuses? Is there still a place for us in this quantum world?
Absolutely. In fact, this paper argues that some of the most valuable skills in the quantum age will be, well, uniquely human skills.
You mean like creativity, critical thinking, problem solving, that kind of thing?
Exactly. Quantum computers, they're great at crunching numbers, processing information. But things like intuition, empathy, coming up with out-of-the-box solutions, that's where humans still have the edge.
So in a way, those human skills become even more valuable because machines can't replicate them.
That's the idea.
Yeah.
And it means we got to rethink how we educate future generations. It's not just about teaching them to code, but to think critically, to be creative, to collaborate, to adapt.
So this research is saying we can't just focus on the technology itself. We got to think about the social, economic, ethical implications too, right?
100%. And one of the biggest ethical questions is access. Who benefits from this technology? Who gets left behind?
It's about equity, making sure everyone has a chance to benefit, not just a privileged few.
Exactly. We've seen it happen with other technologies. The gap between the haves and the have-nots, it widens. And with something as powerful as quantum computing, we've got to make sure it's used to solve global challenges, to lift everyone up.
So it's not just about making the technology work, it's about making it work for everyone.
Could have said it better myself. Quantum computing has incredible potential. But that potential, it can be used for good or for bad. The choices we make now, they matter.
This deep dive has really given us a lot to chew on, hasn't it? It's exciting, it's scary, but it's definitely something we all need to be paying attention to.
I agree. It's like we're standing at the edge of a new frontier, and we have the chance to shape what that frontier looks like.
So as we wrap up, a few key takeaways for our listeners. Quantum computing is real, it's happening now, and it has the potential to change everything. We need to understand both the benefits and the risks, and we need to have open and honest conversations about its implications.
And most importantly, we all have a role to play in shaping the quantum future. By staying informed, asking tough questions, demanding responsible development, we can make sure this technology benefits all of humanity, not just a select few.
That's a great point to end on. Thanks for joining us on this deep dive into the fascinating world of quantum computing. We'll see you next time for another exploration of cutting-edge science and its impact on our world.